Our aim today, solve real-world problems with fractions and mixed numbers, is the exact same aim that we had on Thursday. So today is going to be all about getting some practice in. Just based on our mastery, I didn't feel like we quite got enough practice in. We were also a little bit short on time on Thursday. So I want to make sure that we get plenty of practice here and make sure that we've seen lots of examples, had lots of opportunities to try this out. So during teacher time, you're actually going to work independently on each problem. And then I will go over each problem. So I want you to go ahead and work on this first problem independently. You should be able to do this mostly on your own. So when we look at this first problem, I saw a couple different diagrams. The first diagram I saw was an arrow diagram where people were showing that there was a positive 4 3/4 feet. And they were thinking kind of like, I'm going back in time and I'm going back that 5-6 feet to figure out what it used to be. That's one arrow diagram I saw. The way I would have drawn this diagram would have been to show that this was now 4 years ago. And that this is 4 3/4. And this is 5/6. And so the difference between those two things is what we're looking for, this change between those two things. So both diagrams are totally fine. The first one probably leads to the expression 4 3/4 plus negative 5/6. This other one, when we're thinking about change, we're always thinking about the difference or the subtraction between two things. So I would write this one as 4 3/4 minus 5/6. But we can see after a change switch, these actually end up being the same expression. I don't think that most of you have a problem with actually doing the addition and subtraction of the fractions once you get there. It's reading the problem carefully. So this is just reading carefully. He grew a total of 5-6 feet. We're trying to figure out how tall he was 4 years ago. So I think for a lot of you, if you start thinking through that, that doesn't make a whole lot of sense if we're adding to his height to go back in time. And there were a handful of people I saw doing additions, but I also saw a lot of those people checking the work and going, my answer doesn't make sense. When we go back through this and do the math, should get 19 over 4 plus negative 5 over 6. Common denominator would be 12. It's going to give me 57 over 4. Or excuse me, 57 over 12 plus negative 10 over 12, which would be 47 over 12. And thinking about that in terms of feet would be 3 feet and 11/12, so we're 3 feet 11 inches. Questions about that? Okay, go ahead and do the second half of that problem. When I do that multiplication, I'm going to change this to an improper fraction. It's going to give me negative 7/4 times 6 over 1. I can simplify this. And that's going to give me 10 plus negative 21 over 2. Because this is what was left over on the bottom. This was what was left over on the top. Now we want to go ahead and add that together. 10 plus negative 21 over 2. Get common denominators. 20 over 2 plus negative 21 over 2. It's going to give me negative 1 over 2 degrees. Negative 1/2 degree. Questions about that? Najari? Is that a no? Okay. We're looking for how many square feet does he have left to paint. So the first thing is here, we should notice it's asking how much he has left to paint, not how much he's already painted. That's really important to notice. The other thing is we're told that he has a total of 24 3/5 area. Okay, so we're looking at a box that has an area of 24 3/5. We're told that he has painted 2/5 of the wall. It doesn't say he painted 2/5 of a square foot. It says he painted 2/5 of it. So we want to take this 24 3/5 and we want to break it up into 5 equal parts, and we're saying he has painted 2/5. However, once again, we look at this question, and does this question ask us how much he has painted? No, it asks us how much he has left, which is why a lot of you were thinking about subtraction because you knew that we were taking away some amount. Well, this is what he has left. What fraction does he have left? What fraction of the wall does he have left? Stephen? 3/5. So what's left is 3/5. So if we want to find a fraction of a total, we should remember this from 6th grade and from several problems that we've already done this year. You take whatever your total amount was, and you multiply it by your fraction. If I want to know how much he has left, I want to know what 3/5 of 24 3/5 is. So here we have to change this to mixed numbers. It's going to be 123 over 5 times 3 over 5. It's going to give me 369 25ths. Which is 14 19 25ths square feet. Okay, questions about this?